Okay, so just doing a couple of examples of how we calculate the inverse of a square matrix. So this is just a couple of examples. So remember the method. The method is if A is a square matrix, then to find A inverse, what we do is we write the matrix. So we can say it's an n by n matrix. Then what we do is we write this extremely augmented matrix. A, we put a little vertical line, and we put the n by n identity matrix, and we perform elementary row operations. With the goal of reducing the left-hand side to the identity matrix. And when we do that, the resulting right-hand side is exactly the inverse matrix. So in order to do this, you have to, similar to doing row reduction, in fact it's identical to doing row reduction, but basically you look at this component here and you sort of do the elementary row operations to sort of put this component into reduced row echelon form, which is actually the same thing as the identity matrix. And when you do that, you're working across all of the rows, so you're also modifying the right-hand side. And the end result of the right half is the inverse matrix. There's an important note, though, is that note, if you cannot turn A into IN, so in other words, if you can't do these row operations on A so that the left-hand side of this giant matrix, which has an A, turns into the left-hand side here, which is the identity, if you cannot do this, then that means that A is not invertible. Anyways, but this is the method. It's just basically you do the elementary row operations and try to get the identity. Okay, so here let's do an example, because this is all about just doing a few examples. So here's one example. So if A is the matrix, say 1, 4, 2, 7, so it's a 2 by 2 matrix, then, so let's find A inverse. So the method says that what you do is you write this matrix. Since it's a 2 by 2 matrix, we're going to put next to it the 2 by 2 identity matrix, and whether or not you write this vertical line or not is irrelevant. And now you're just going to perform a sequence of elementary row operations in order to turn the left-hand side into the identity matrix. You can do really whatever you want as long as it's an elementary row operation. So for example, we can leave the first row alone, and then we can take the second row and subtract from it twice the first row. So 2 minus 2 times 1, 7 minus 2 times 4 gives us a negative 1, 0 minus 2 times 1 gives us a negative 2, and that just becomes a 1. So you can check that that's alright. So all we did was we modified the second row on the left side. Sorry, the second row. Let me start using a different color. You can't see what I'm pointing at. So we just modified this row by subtracting from it twice that row. Okay, so if you double the top, you get 2, 8, 2, 0, so 2 minus 2 gives you the 0, 7 minus 8 gives you the negative 1, 0 minus 2 gives you minus 2, and 1 minus 0 is still 1. Okay, and you basically just want to get comfortable doing this. So now we can negate the second row, leave the first row alone, for example, and that becomes 0, 1, 2, minus 1. So all we're doing is we're going to just negate row 2. So alright, and so as you can see, I'll put the barrier set up, you can see. So we've done an elementary row operation, and we're not quite at the identity. To get the identity, we still need to do something to turn that into a 0, and there's pretty much just one thing we can do. So now let's do one more step, and now we're going to do the first row. We're going to subtract from it 4 times the second row. So we're going to leave the second row alone, so we can just rewrite it, and now we're going to modify the first row. So you're looking at the first row. 1 minus 4 times 0 is still 1. 4 minus 4 times 1 is 0. Then you're going to do 1 minus 4 times 2, so that's 1 minus 8 gives you a negative 7. And then you're going to do 0 minus 4, that becomes a plus 4. And so at this stage, we have performed a sequence of row operations, and we've turned the left-hand side over here into the identity matrix. And according to the method, what that says is that this right-hand side here is A inverse. That's the inverse matrix. And so we can just confirm that by checking. So let's do a quick check. So check. So by definition, if it's an inverse matrix, then that means when you do matrix multiplication, you should get, in this case, the 2 by 2 identity matrix. And it should get the identity matrix no matter if you swap the order of multiplication. So that's what I wrote over here. I swap the order. Because in general, order matters when you're doing matrix multiplication. And so let's just check. So A is, I'll just stick what we had before. So A is 1, 4, 2, 7. We're going to multiply that by what we hope to be A inverse, minus 7, 2, 4, minus 1. And when we do that, we'll see what we get. So I'll use blue for what it should be equal to. So now we're just going to do matrix multiplication. And, I'm just going to do it. So you get minus 7 plus 8 here. Here you get...
Are you talking to someone?
I'm talking to myself. And now people have heard you. So my wife is also working from home. And then let's do the last column. So that gives you 4 minus 4. Sorry, 4 minus 4 and 8 minus 7. Which of course is the same thing as 1, 0, 0, 1. So yay! So we found A inverse. So indeed, the inverse of the matrix 1, 4, 2, 7 is the matrix minus 7.